All right, let's go. Concept of limiting and excess reagents, how to determine the number of particles, the number of moles, more calculations. So we are saying a mole is the amount of substance that contains as many particles or entities as there are in exactly 12 grams of carbon-12 isotope. That is what we call as a mole. Now, what we mean is when we are talking about one mole of something, what does one mole of something mean? So one mole of a substance is equal to 6.022 times 10 to the power 23. One, it can be particles. It can also be this same number of molecules. It can also be this same number of atoms and just a lot of things. That is one mole. One mole represents this number. Does anyone know what we call this number? What's this number? Yes, Musonda. Yes, Avogadro's constant. So one mole is equal to Avogadro's particles, number of particles or molecules or atoms. So if they say, imagine we have got a question, they say how many atoms are in, let's say, 2 moles of oxygen. That's the question. How many atoms are in 2 moles of oxygen? So to be able to calculate the number of atoms in 2 moles of oxygen, you are going to just get that relationship. 1 mole of oxygen is equal to 6.022 times 10 to the power 23 atoms. And then you are going to say what of 2 moles of oxygen? That is going to be equal to x. So just determine this x. So x is going to be 2 multiplied by 6.022 times 10 to the power 23 atoms. These are the number of atoms of oxygen in 2 moles. Hope we get that, and that is very important for understanding. Now, when you're talking about more calculation, you should be able to write balanced chemical reactions or chemical equations. So, if they give you a weight equation, you should be able to make a balanced chemical equation and such. So, let's say we've been given a chemical reaction, and we're talking about the reaction of aluminium with oxygen. So how can we write a balanced chemical reaction between aluminum and oxygen? So one thing that you need to know is you need to know the valence of these atoms. And how do you tell the valence? You need to check in which group that atom is. For example, aluminium is in group, okay, aluminium is in group 3. Because it is in group 3, then it has got a valence of 3. So how do you tell the valence? You have got group 1, group 2, group 3, group 4, group 5, 6, 7, and group 8. So the valence, group 1 elements have got a valence of 1. That means they are going to lose 1 electron to be stable. Group 2 have got a valence of 2. Group 3 have got a valence of 3. Group 4 have got a valence of 4. But when you get to group 5, you are going to start reducing. So group 5, they are also going to have a valence of 3. Group 6 are going to have a valence of 2. Group 7 have got a valence of 1. Group 8 have got a valence of 0. That's why these are called inert gases. They don't react, like they are stable already. So that is how you get to determine the valence. And how did we find these valences? It is 8 minus a group number. So 8 minus 5, that will give you 3. 8 minus 6, that will give you 2. 8 minus 7, that gives you 1. So that is what one thing we need to take note of. So we are saying aluminium is in group 3, meaning it has got a valence of 3. When we react this with oxygen and oxygen, well, again, we need to know this. When you check on the periodic table, just make a sketch of the periodic table. There is a separation of metals and non-metals. We have got what we call the atomic gases. There is a certain place where you're going to cut the periodic table like this. These are the non-metals, and then these are the metals here. But when it comes to some elements, elements such as oxygen, they always exist with a 2 down. Nitrogen always exists with a 2 down. Chlorine always exists with a 2 down. Hydrogen, fluorine. Every time you are using these elements, you always need to have a 2. They all exist as diatomic elements. So you can't write oxygen like this. No, that's not right. That is because oxygen always exists as a diatomic gas. So please take note of those everything there. So oxygen, we are going to put a 2 there always. So aluminium is a solid. Oxygen is a gas. Now, the valence of aluminium is a 3. The valence of oxygen, oxygen is in group 6, meaning it has a valence of 2. How do we find the 2? It is 8 minus 6. So let me put the 2 there. So when these two react, we are going to form aluminium oxide. This 2 is going to come here, and then the 3 is going to come here. So this is aluminium oxide. Now this equation is not balanced. You can see we have one aluminium here, but we have got two aluminiums there. And then we have got two oxygens here, but we have got three oxygens here. The first thing that we're going to do is to balance the oxygen. How do we balance? We are going to swap these two numbers. So I'm going to put a 3 here. I'm going to put a 2 here. And then we can see now we have got 2 times 2. That gives us 4 aluminiums. So I'm going to put a 4 here. So this is the balanced chemical reaction. Well, aluminium oxide is a solid, bauxite. So this is the balanced chemical reaction between aluminium and oxygen. So when you have got a question anywhere, please be sure to ask. When you want to determine the balanced chemical reaction between magnesium and fluorine, the periodic table is something that will always be provided, so you don't need to worry about it. Magnesium and fluorine. Well, the symbol for magnesium is Mg. This is a solid. And fluorine is a diatomic gas also. It's a gas. So when these two came to react, we are going to form magnesium fluoride. But we need also to know the valence of magnesium. Magnesium is in group 2. It has got a valence of 2. Fluorine is an halogen. It is in group 7, so it has got a valence of 1. So what is going to happen is these numbers are going to swap. This one is going to come on the magnesium to be there, and then the 2 come on the aluminum to be there. But we don't show a 1 when you are writing a chemical reaction, so just write it like this. So this is magnesium fluoride. That's a chemical symbol. And for this one, it is already balanced because you can see we have got 1 magnesium, 2 fluorines, even here 1 magnesium, 2 fluorines. So that's a balanced reaction. Other common reactions that we need to know is the reaction between an acid, and it can be a base or a carbonate or even a metal. So when an acid reacts with a base, this is always going to form a salt and water. So an acid, most you are going to see they contain an hydrogen. For example, hydrochloric acid. Well, if you see this HCl, it has got a state symbol of aqueous, then that is hydrochloric acid. But if this was gas, then that is hydrogen fluoride. And then if this one reacts with a base, an example of a base I can give, bases are mostly hydroxides or oxides. I can give a simple example, sodium hydroxide. This is also in aqueous, meaning dissolved in water. What you are going to see is that this hydrogen is going to interact with the hydroxide here. So whenever you are forming a reaction, you need to know which part of that compound is positive and which part of that compound is negative. In this compound, what is acting as a metal, what is acting as a non-metal? So the hydrogen is positively charged. The chlorine is negative. In this compound, sodium is a metal, it is positively charged. The hydroxide is negative. So they are going to swap. What is positive in one is going to interact with what is negative in the other. That's why the hydrogen interacts with the hydroxide, the chlorine with the sodium. So when the chlorine interacts with the sodium, we're going to form sodium chloride. Well, sodium is in group 1. Chlorine is also in group 7. They both have a valence of 1. Therefore, that will just be the symbol without any number down there. Sodium chloride, this is table salt and it can dissolve in water. So we're going to put aqueous as a state symbol, and then we're going to have water being formed. So is this reaction balanced? We can see two hydrogens, and then we've got two hydrogens. One oxygen there, got one oxygen there, sodium 1, got one sodium, and then chlorine 1, also one chlorine there. So it is a balanced reaction. Another example that we can talk of is sulfuric acid in aqueous. It reacts with, let's say, barium hydroxide, also in aqueous. What are we going to form? So the hydrogen is positive, the hydroxide is negative. So those are going to interact to form water. The barium is going to interact with the sulfate. Now, again, we need to know what is called radicals. So radicals are a group of atoms together with one valency. For example, a sulfate. Sulfur and oxygen together, they've got a valence of 2. This is a radical, a group of atoms. We have got phosphates. They've got a valence of 3. They are together. We have got carbonates. They've got a valence of 2 together. So we need to know some common radicals by now, and we expected that we know that from high school. Okay, these are some things that we need to know. Now, let's understand more calculations using these chemical reactions. Imagine 2 grams of, let's say, hydrochloric acid reacts with, let's say, okay, I'm going to give a very simple example. Hydrochloric acid reacts with sodium hydroxide. So we want to determine how much of salt is formed. How many grams of salt is formed? That's our question. 2 grams of hydrochloric acid reacts with sodium hydroxide. How many grams of salt is formed? Now the first thing you need to know is, for you to determine how many grams of salt is formed, first determine the balanced chemical reaction. So in here we've got hydrochloric acid, which is in aqueous. Of course, even state symbols you can leave them unless if they have asked you to write the equation including state symbols. And then this is reacting with sodium hydroxide. What you are going to form here is sodium chloride and water. Now, which one of these product is a salt? Remember, the question is saying how many grams of salt is formed. So what is formed is on the product side. Obviously, this is not the salt, so the salt is sodium chloride. So the information we've been given is we've been given 2 grams of hydrochloric acid, and we want the mass of here, the mass of sodium chloride. And what we're going to use is a mole to mole ratio. So the number of moles of what we know, the number of moles of hydrochloric acid should be equal to the number of moles of the salt that has been formed, sodium chloride. That's the interaction which is here. You can see there is a 1 in front here, there's also a 1 in front here. You are supposed to divide by those coefficients, but because they're both ones, I'm not going to show that. So how do you again determine the number of moles? Number of moles when you've been given the mass is given by mass over molar mass. So this is going to be mass over molar mass of hydrochloric acid, and that is going to be equal to mass over molar mass of the sodium chloride. So now we need to know the mass and the molar mass for the hydrochloric acid and the sodium chloride. Or let's get this from the periodic table. Okay, so we are here now. Firstly, what I'm going to do is I'm going to write, because we need to have the molar mass for hydrochloric acid and also for sodium chloride. So here we've got chlorine, we've got also hydrogen. Now chlorine is 35.5, that's the molar mass. Hydrogen, let's just use 1, or we can say 1.008, but we can use 1 is fine. And then chlorine here is 35.5. Sodium should be 23. Yeah, that's 23. Of course, the periodic table is showing 22 point something. So 35.5 plus 1, that is 36.5. And then we add the other one. If you have got a calculator, please go on and punch that. So that is going to give us 58.5. Okay, so we are now going to go on. We are going to get the mass of hydrochloric acid that we've been given, and that is 2 grams. Divide by the molar mass of hydrochloric acid, we can see that is 36.5. And that should be equal to the mass of sodium chloride. Now, the mass of sodium chloride, that is what we are looking for, divided by the molar mass of sodium chloride, that is 58.5. So therefore, the mass of sodium chloride is going to be equal to, we're going to get this number, we multiply by this number. That is going to be 2 multiplied by 58.5. And then we're going to divide. We can see this number is supposed to multiply the sodium chloride, but we don't want that. So we're going to instead divide. Okay. The 36.5 is going to be divided. If you want, you can say this times this is equal to this times this, and then later on now you come to divide. Is this making sense, or there is a question somewhere? Any question? So the mass we're going to get is 3.2 grams of sodium chloride. This is the mass that we're going to get for sodium chloride being produced. Are we fine with this? Now another question can say how many particles of sodium chloride are produced? How many particles of sodium chloride are produced? Now, to be able to determine the number of particles of sodium chloride that are produced, we first need to determine the number of moles, or even the mass of sodium chloride that is produced. So let's first find the number of moles of sodium chloride produced. Number of moles of sodium chloride, we know that that is given by mass divided by the molar mass. Now in this case, the mass that we have that is produced is a 3.2. The molar mass of sodium chloride is 58.5. So let's get that. 3.2 divided by 58.5. That is going to give us 0.0547. Now that we've determined the number of moles of sodium chloride that is produced, now we're going to use the relationship. We know that one mole of anything, in this case 1 mole of sodium chloride, is going to be 6.022 times 10 to the power 23 particles. Remember, we want to determine the number of particles. If we wanted to determine the number of atoms, we would have said atoms. Now what of 0.0547? 0.547 moles. What is it going to give us? X. So let's just determine this X. Then we have found the number of particles. Therefore, X is going to be equal to 0.0547 multiplied by 6.022 times 10 to the power 23. So just punch that on your calculator. What you get is the number of particles that you are interested in. Do you have any questions? All right. So let's look at another thing. Now, the operation is going to become a little bit different when the mass or the moles of both reactants are given. You can see in this question only the mass of hydrochloric acid was given. The mass for sodium hydroxide wasn't given. But what if both are given? How does the question go now? Let's say 3 grams of, we can say, sulfuric acid reacts with, we can say, 2.5 grams of calcium carbonate. Okay, so the first question is determine the mass of salt formed and then the second one we're going to work out is the moles of water which are formed. Okay, let's work it out. The first thing, please, we need to get a balanced chemical reaction from the statement given. We have got 3 grams of sulfuric acid reacting with 2.5 grams of calcium carbonate. So let's get a balanced chemical reaction. Sulfuric acid is H2SO4, and this is reacting with calcium carbonate. Or for calcium carbonate, we saw that a carbonate is like this. It has got a valence of 2, and then calcium also has a valence of 2. So when these react, more like these are going to cancel out because this one is positive, the calcium. So what you're going to have is calcium carbonate is just like that. So when this is reacting, the sulfate in this case is negative, the hydrogen is positive, the calcium here is positive, the carbonate is negative. So these are going to swap. What is positive in one reaction is going to go with what is negative in the other reaction. So the hydrogen is going to go with the calcium. But you need to know that when acids are reacting with metal carbonates, what you are going to form, please, this one you need to know. We did this in high school. We are going to form a salt, water, and carbon dioxide. So what salt are we going to have from here? So this is going to be the calcium and the sulfate. So that salt is going to be calcium sulfate. So the calcium has got a valence of 2. Sulfate has also a valence of 2. That's why we are seeing it like this. Otherwise, if this was maybe phosphoric acid and it was something, let's say like this, and you are reacting with calcium carbonate. When the calcium reacts with the carbonate, we are going to have calcium phosphate like that. I mean, when the calcium reacts with the phosphate, calcium has got a valence of 2, phosphate has got a valence of 3. So what would have happened is the 3 from the sulfate would have come here, and then the 2 from the calcium would have come here. So that would have been the formula, but that's not the case. So because they've got both a valence of 2, that's why the formula just goes direct like that. And then you're going to have carbon dioxide and also water. Now, is this reaction balanced? We need to check out. we see we have got 4 oxygens here plus these 3, we've got 7. And then we've got 4 plus 2 plus 1, that's also 7. And if you can check the hydrogens on the reactants, there are only 2. The hydrogens here, they are also 2. Sulfur only 1, sulfur only 1. Calcium 1, calcium 1. Carbon 1, carbon 1. So everything else is balanced. So it is just balanced in this state. Now, I want something that we are going to use. At least there is a number in front so that we see the difference from the previous one we've done. In this case, let me just use a simple one. Instead of sulfuric acid, let's use hydrochloric acid so that the reaction is going to come out. So in case of hydrochloric acid, we are going to have HCl plus the same calcium carbonate, and this is going to give us calcium chloride. This is the one which is negative, the hydrogen is positive, and here this is positive, this is negative. So the calcium is going to react with the chlorine to form calcium chloride. Now, the chlorine is in group 7. It has got a valence of 1. Calcium has got a valence of 2. So these are going to swap. These 2 from the calcium is going to go on the chlorine. And so we're going to see calcium chloride with a 2 here for the chlorine. And then we're going to have carbon dioxide and water. Is the reaction balanced? Let's check out. We have got 2 chlorines here. We only have 1 chlorine here. So we need to balance out the chlorine. So we're going to put a 2 in front here. Okay, when we put a 2 in front, that is going to make the hydrogen 2. What of this side? Well, the hydrogens are already 2, so that's fine. The oxygens, we can see there are 3 here. Well, here we have got 2 plus 1, that is also 3. So everything is now balanced, just that 2 we've put on the hydrochloric acid. Now, if you check the data that we've been given 3 grams of hydrochloric acid. We've been given also 2.5 grams of calcium carbonate. Now, when you've been given the mass of both reactants or the moles of both reactants, then in this case you need to determine which one, when this calcium carbonate reacts with the hydrochloric acid, which one is going to be used up first, which one is going to finish first. Take for example, you are cooking. You have got the water and you have got the millimole. You want to determine how much nshima you are going to cook. So what will determine how much nshima you are going to cook is what is limiting or what is going to be used up first. Imagine you only have a cup of millimole and then you have got a jug of water. You want to use the whole jug of water. That is not going to work out. So you look at what is small. That is why we need to look at which one of this is going to be used up first. And how do you determine that? You need to look at the number of moles of hydrochloric acid and the number of moles of calcium carbonate, and then you get to compare those. Now, that should have been my first question here. So, determine the limiting reagent. And these questions carry a lot of marks, like 7 marks, so you need to show steps. So the question is, what is a limiting reagent? So a reactant that is used up first in a chemical reaction is what we call a limiting reagent. And then the other one which remained is called the excess reagent. Excess reagent is a reagent or reactant that remains after a chemical reaction is complete. So in this case, we're going to start with the first one, C. We're going to start with C. Let's take it as A. We determine the limiting reagent. So what I'm going to do is, you can take any. Imagine like you haven't been given like the mass for any of these. But before we do that, let's determine the molar masses of hydrochloric acid and also calcium carbonate. Chlorine, we know that is 35.5. Hydrogen, that's the one. So that is 36.5. And then we go to the calcium carbonate. Oxygen, we know that is 16. I'm using rounded off values. You can also say 15.9994 multiplied by 3 because we have got 3 of them. Carbon, that is a 12. Calcium should be 40. Let me just confirm that. Okay, that is 40. So what we are doing is first 16 multiplied by 3, which is a 48. And then we are adding 48 plus 12 plus 40. And that is 100. So it's up to you to decide. Just take one of them. Consider it as if they've not given you the mass. That is up to you to determine which one you're going to consider as they've not given you the mass. So in this case, let me take that I don't know the mass for calcium carbonate. So I'm going to use the mole relationship to determine the mass of calcium carbonate that I should react with 3 grams of hydrochloric acid. And how do we do that? So the number of moles of hydrochloric acid over the coefficient. The coefficient is 2. That's that number in front of the hydrochloric acid. Should be equal to the number of moles of calcium carbonate over the coefficient. Now in this one, calcium carbonate in the balanced reaction is 1. That is why you need to make sure that the reaction is ever balanced. Now, how do we again determine the number of moles? Number of moles is given by mass over molar mass. So this will become mass over molar mass. But remember, we already have a 2 down, so it will be mass over 2 molar mass of hydrochloric acid. This is going to be equal to mass over molar mass of calcium carbonate. So what we want to determine is the mass of calcium carbonate. We are taking it that we don't know the mass which is given. So let's put the mass of hydrochloric acid that we have. That is 3 grams from the question. And then divided by 2 times the molar mass for hydrochloric acid. You can see that is 36.5. This should be equal to the mass of calcium carbonate divided by the molar mass. The molar mass of calcium carbonate, that's 100. So let's determine now the mass. So mass therefore is going to be, I said, just multiply this and this. That is going to give us a 300. And then divide by this thing which is supposed to multiply the m. That's the one we're going to divide by 2 times 36.5. Okay, let's see what that gives us. 300 divided by 2 multiplied by 36.5. So that is going to give us 4.1. And this is mass, it is in grams. So the next thing now we're going to do is compare the mass that you, this is the mass that is supposed to react with with 3 grams of hydrochloric acid. Now look at the mass that we've been given. We've been given 2.5 grams. Now my question is this 2.5 grams going to react with 3 grams of hydrochloric acid and the whole of it finishes? Or the 2.5 grams of calcium carbonate is going to be all used up, it is all going to finish? What do you say? Is the mass of calcium carbonate which you've been given 2.5 going to react completely with 3 grams of hydrochloric acid, or the whole of these 2.5 grams is going to be used and then we're going to have some hydrochloric acid remaining? What are you going to say for that one? Yes, Musonda.
I think it will be used up, then the hydrochloric acid will remain in excess.
Okay, good. That is exactly the correct thing. So if you can see, comparing the mass of calcium carbonate that is available with the mass that you need, what you need is more than what is available. Because of that, calcium carbonate is all going to be used up. Therefore, calcium carbonate is a limiting reagent. So if a question came and you even see it even reads 7 marks or 5 marks, determine the limiting reagent, show you're working. So after you've done the calculation, you need now to conclude. Since the mass of calcium carbonate that is available is less than the mass of calcium carbonate that is expected to be used, then calcium carbonate is the limiting reagent. Okay, good. We've already determined the limiting reagent. Now, again, you need to know that the limiting reagent is what determines the is the one that is going to determine the amount of product. Always, the limiting reagent determines the amount of product. Even if the question doesn't specify or it doesn't say find the limiting reagent. If they have given you both masses for the reactants, that should be the first thing. Determine which one is going to be the limiting reagent. So now let's work out part this one here. Determine the mass of salt formed. So the salt which we have is calcium chloride. Again, we need to determine its molar mass. We have got two chlorines and each is 35.5. Then we've got calcium which has got a mass of 40. So 35.5 multiplied by 2, that is going to give us a 70. And 70 plus 40, that is 110. So we can now determine, we know the limiting reagent. That's the one that we're going to use to be able to see the amount of product formed. We're going to say the mass of calcium carbonate divided by the molar mass of calcium carbonate. That should be equal to the mass of calcium chloride divided by the molar mass of calcium chloride. The mass of calcium carbonate we have is 2.5. Molar mass of calcium carbonate is 100. That should be equal to the mass of calcium chloride, that's what we are looking for, divided by the molar mass of calcium chloride, that is 110. So to be able to find the mass is going to be equal to 2.5 multiplied by 110 divided by 100. Yes, Chisenga. Chisenga, go on. So this is going to give us 2.75 grams of calcium chloride. This is the mass of calcium chloride that is going to be formed. Is there any question? Do you have questions? All right. Now the next question is saying find the moles of water formed. So the moles of water formed, if you can see in this reaction, considering the limiting reagent with the water, the mole ratio of the limiting reagent and water is 1 to 1. So to be able to find the mass of water, I mean the moles of water that is formed, number of moles of the calcium carbonate over the coefficient which is 1 should be equal to the number of moles of water over the coefficient which is 1. Now don't put the ones down, like it doesn't change anything. So it just tells us that the number of moles of calcium carbonate is equal to the number of moles of water. And how do we find the number of moles of calcium carbonate? It's mass over molar mass. In this case, the mass calcium carbonate is 2.5. Molar mass for calcium carbonate is 100. So what will it be? Decimal point is going to move twice. 1, 2. So we're going to have a 0 there and the 0 here. So the answer is just 0.025 moles. These are the moles of water that are going to be formed. If you want to calculate the mass of water that is formed, number of moles is given by mass over molar mass, meaning that mass is equal to number of moles times molar mass. So just multiply this number of moles times the molar mass of water, that is 18. That will give you the mass of water that is formed. Is that a question, please? Okay, let's add the question. So how many ions? That should be part D. How many chloride ions are formed? That's our question. So how many chloride ions are formed in this question? Now, where are the chloride ions? So let me ask, in which compound are we going to find the chloride ions to be formed? In which compound are we going to find the chloride ions formed? So look at the product. Whenever you're talking about being formed, that should be on the product side. So on the product side, which compound contains is going to contain chloride ions? So that is the calcium chloride. This is an ionic compound. That is because it contains a metal and a non-metal. Now I want to find how many chlorine ions are formed. Chloride ions are formed. What we are going to do is we need first to determine the number of moles of this compound that is formed. That is the first thing. So number of moles of calcium chloride is given by mass divided by the molar mass. And the mass of calcium chloride that is formed, we can say that is 2.75. The molar mass of calcium chloride, we determine that as 110. So let's see what we get. So that will give us 0.025. So these are the moles of calcium chloride that are formed in this reaction. And next thing that you need to do, you need to disassociate calcium chloride. You see how many moles of chlorine are there in calcium chloride. And how do we get to do that? Well, not complex. We've got calcium chloride. When calcium chloride breaks, we are going to have calcium ions. The charge for calcium is 2 plus. And then we are going to have chlorine ions, Cl. The charge for each chlorine is just a negative. That is because chlorine is in group 7, so it only gains 1 electron. Now you can see we have got 2 chlorines here. So we need to balance the reaction. We're going to put a 2 in front here. So this is what happens when the calcium chloride disassociates. So we can see that for each 1 mole of calcium chloride, we have got 2 moles of chlorine ion. For each 1 mole of calcium chloride, there are 2 moles of chlorine ions. But the moles of calcium chloride which are formed here is 0.025. So the question is how many chlorine ions are going to be formed? So that is what we want to find. We want to find x. So if we multiply this x times 1 there, that will just be x. So x is going to be 2 multiplied by 0.025. Okay, so that is going to give us 0.05. These are moles of chlorine ion which are formed. Now remember the question is saying how many chlorine ions. It is not moles. How many chlorine ions? Not the moles of chlorine ions, but how many chlorine ions are formed. So to be able to find how many chlorine ions are formed, we also use the same relationship that we found out. So 1 mole of chlorine ions is equal to 6.022 times 10 to the power 23 ions. So 1 mole of anything is equal to 6.02 times 10 to the power 23 particles, ions, molecules, atoms. Now we have the number of moles there. So what of 0.05 moles? how many ions are going to be there. So our aim is to find x. So x is simply 0.05 multiplied by 6.022 times 10 to the power 23. So if we get that value, then we've determined the number of ions. Any questions? So that will give us really a very big number. So we can find out the answer there. That will be the number of ions that we're going to find in this question.